but I think I'll put my.
And we are live.
Ready?
You're ready, please.
So.
That's good. There you go. I can.
How many people on mine? How many people? Well, welcome to Bay High's program for September 2025. And Bay High is the local chapter of ACM's SIG Chi. ACM has 75,000 members. I'm Ted Selper. I'm the chairman of Bay High. And we have we have the vice chair right here, Edwin. But the thing I want to say is that this special interest group meets monthly, and we've had all of the most fabulous speakers that the community of human computer interaction have to offer. It's been a really big pleasure of mine to host these people. And the archive of them is on YouTube, but you can also find it on Bay Hi, our website, and you can go through the calendar and find these amazing speakers. There's a couple hundred talks, so you know, please do that. And we have a little bit of food for the talks, and we have the computing that we need to do and stuff like that. It costs a little bit of money to run this organization, so consider joining. It's all volunteer organization, and I'm the program chair at the moment. Anybody that wants to is welcome to get involved with helping the organization. You can help, like for example, we are considering having some field trips. We've had a few in the past. We've gone to Da Vinci, let people at Bay Hi play with the robot to do surgery. Went to the ground traffic control for all of Asia Pacific, running out of Fremont, and watched them try to land Kamala Harris as the airplane, which meant rerouting everybody. So we have the need for publicity and in-person coordination. All these people do work, and we appreciate them. And on the first Tuesday of the month, people get together online and talk about what Bay Hi should become, and also talk a little bit about themselves. It's just an hour, so please consider coming to that meeting. So tonight we have the legendary Richard Burton. He's legendary to me because before I came to Park, which I only did for a year, I heard about his work and I was delighted. I was already working on Intelligent Turoring Systems a little bit, and he did some of the most famous, wonderful, and I don't have the book here, Intelligent Tutoring Systems, but some of the really seminal work that people that really got the field started. And what was special, I was talking earlier about, that happened at Park with people like Richard, not everybody, but Richard is one of them, who had ideas and then built them and then tested on themselves. And that was really somehow it was different from the waterfall thing where, you know, you have somebody designing or telling somebody else to do something and they do it, and then you ship it as a product, usually without testing, which is what used to happen back then. And so he did lots of interesting things. One of the things that I was most impressed with and intimidated about going to find him and asked about when I went to work there was he made a version editor, and a version editor is that wonderful thing in Word where you can turn on revisions and you can accept or not, and you can see who made the revisions. And that was super, super fancy back in, well, 1983 is when I remember finding out about it. So, these are not what we're going to talk about tonight. I'm just telling you about this man that I'm delighted to have here. What he's going to talk about is a tutoring system that he's been working on a long time and had incredible success with, using some of the famed old AI approaches. And there are reasons that people used to talk about why knowledge engineering was a really wonderful thing for teaching people about what they already knew. And so as people like to take the experts and codify their knowledge, and that was going to change everything. And a lot of people were just not careful enough about it, or not systematic enough about it, or they're too ambitious about what they try to do with it, and didn't have the successes that I think we're going to hear about tonight. And so I think it's really important now with the new AI directions that people are talking about, for us to recognize that representation always matters. Representation, reasoning, and learning are the three things I think of as AI, and that and that there are lots of ways of thinking about what you're going to do with your AI, and that if you don't think about it hard, you aren't going to end up with success. So that's my takeaway. But it really isn't fair for me to take so much time with me. I'm going to relinquish my presentation, and somehow or other I'm going to get rid of it, and we're going to see if we can get you to share, Richard, and say hello to us as soon as you have resumed your slideshow and made sure it has the slide descriptions that you want. You're going to get the controls for Zoom for PowerPoint.
Right. Right. How do you do that?
There you did it.
Start the program.
Yeah, beginning and then resume slideshow.
Resume the slideshow.
And then we have to do the one more thing, which is those three dots.
Which is three dots. To say, hide the presenter, that turns it off. And then when I turn it back on, then you guys should be getting the full
We're all
screen.
very happy. Okay. And welcome everybody.
I know. Okay, so thank you. It's good to talk to the people in the room and all the people out in the on the internet. Do we have any idea how many people are out there?
There's at least 10.
There are at least 10. Great. That so I have spent a long time doing research into intelligent tutoring systems, and I eventually gave up on it and restarted when I joined a startup company in 2004. And the startup company had the goal of building an excellent computer tutor for a real large domain and see it used. So I've been doing research and building small things, but I really wanted to join a team that was actually going to build something and see it through and do a real world thing with it. The guys I was joining had all of the right inclinations and attitudes. So we got busy and we got some DARPA contracts to build a digital tutor. And the domain they wanted us to handle was Navy recruits, and they wanted us to teach them how to do IT on computer installations in the Navy. So what they wanted was for us to build an intelligent tutoring system that would basically take a recruit out of boot camp and train them up so that they could work as the IT for any installation, computer installation in the in the world. So our development strategy. So what made us think that we would have any chance at all at making solving this problem, since I've been working on it for 30 or 40 years. I haven't yet produced such a system. What made us think we could do it? Well, the strategy that we had been following was trying to build representations of knowledge and understand knowledge better and look at what experts do and try to model experts and all of that stuff. But the idea that was put forth by this company was that what we ought to do is we ought to look and see what the world's best tutors do, the best tutors in the world. And we ought to write a computer program that mimics what their behavior is. So we're not going to try to understand what they do, we're just going to mimic it. And after 50 years of programming, I know I'm good at writing computer programs. So I can mimic any behavior that you can specify. And so that seemed like that's a doable problem. So I'm going to get into this. So the first problem that you have with this is that requires finding experts and recording them, teaching one-on-one to a target population of what you want. And so we looked at this and said, okay, let's build a school. So to generate our expert teaching behaviors, we established a school, an naval facility down in Monterey. We hired 24 nationally known experts to do the tutoring. And the Navy supplied 15 naval recruits, guys who were fresh out of boot camp, who took our course instead of their standard IT training class. And we ran a 12-week course that covered all of the IT subjects that we thought the Navy would need. One of the reasons we were running it is because we didn't actually know all the material that we were going to need. There was a syllabus that the Navy had, and we had been doing some early experiments with developing something to cover some of those parts. And we had written something that would take 2 weeks of tutoring, and it covered 90% of what it was that they covered in their 6-week course. And so we knew if we were going to teach a 12-week course, we needed a lot more material. And so we thought, well, we'll get the experts to tell us what that material should be for covering the Navy, what the Navy needs. So we ran a 12-week course with IT subjects that the Navy needed and recording all the teaching interactions from screen and room cameras and kept that. So that was the idea. And so a day in the life of the school of this, we had cubicles that we had to build. And starting at 9 o'clock in the morning, we would have the tutor work for 3 hours with a student, then break for lunch, and then work for 2 more hours with that student, and then have another student come in the afternoon, and then work for 2 hours on him, and then break an hour for dinner, and then spend the rest of 3 hours before turning off at 10 o'clock. So if that sounds like it's a marathon, it was. We absolutely destroyed our tutors. They were completely exhausted. The one saving grace in this whole thing is that there were meal breaks for lunch and dinner. So we ended up, due to the lack of food options on the base, which they had one cafe, and it shut down at 1 o'clock, so we couldn't get there, and it was not providing food for a real diet. So I ended up suggesting that we turn the conference room into a dining room, cater it for lunch and dinner. And what they ended up doing, we actually found Whole Foods to cater it in, so we had healthy meals brought in. So they had 2 healthy meals a day, and they could exit from their exhausted period of time and come and sit and just eat pleasant food and talk to their colleagues for an hour before they had to go back and do it again. So it's trying to make it as easy as possible for what was going on. And it turns out that they ended up spending a lot of time sharing their experiences and getting feedback. And so you can imagine this, we have 8 of the experts on various different subjects, all of whom are very interested in teaching and tutoring, talking to each other when they're spending 10 hours a day tutoring students one-on-one. So this just turned into a tremendous sort of melting pot of great tutoring ideas. And so it was very common for the tutors to discuss, a tutor would have a difficulty in the morning. They would have a student having some difficulty, and they could bring that problem into lunch and talk to other tutors about it, and get a suggestion for it and go back and improve it in the afternoon. So the tutors themselves were learning in a way that they probably never had the opportunity to do in their life before. So that worked out really well.
Did you report any of that, or was it just kind of ad hoc observation?
I don't know. This gentleman is Eric Bailey, who was also working with me, and might know better, but I don't believe that. I think we sort of consider those conversations to be private. Do you remember?
The table discussions were definitely private. We didn't have cameras or microphones in those rooms. But the rooms with the tutor and the student, we instrumented everything that was going on, whatever we could. The computers, we had microphones, we were able to not get too far, but we tried to capture as much of the data as possible.
Yeah, we didn't want any. I mean, we wanted the tutors to be able to discuss very personal aspects about students and of course other people, and so we did not collect that data.
Question,
Yeah,
did each tutor have the same student for the whole period, or was they straight up?
no, we had experts in different things. So we had a guy who was an expert in Exchange server. And Exchange server is so complicated that there's only one guy who can do that. So he would have to teach all 15 of the students 2 at a time. So each tutor in the course of their tutoring would basically get 7 different opportunities to work through their tutoring in the course of it. And so they ended up with the opportunity to improve their descriptions of how to order to do things, what the exercises were. And so by the time we got done with it, that's, the 7th week, that was a much better, well-designed course, well worked out that we had. So one of the things that we learned about, so there are a bunch of things that we learned that turned up in this, and one of them was how quickly it was that the students were learning. One way to communicate this is there were some experts that we could only get for a week. And so there'd be university professors who could take off more time than that, but were specialists on something that we needed to have covered. And so we would tell them, hey, come in, bring a curriculum that's going to take a week worth of curriculum material. And so a common experience to have when one of these guys was coming in and tutoring a student on Monday morning was at Monday lunch, he would be saying, I got through almost my entire week's worth of curriculum this morning. And so I'm going to have to, go back and extend it and figure out what I'm going to teach for the next 4 days. And one of them was a university professor who got through his entire introductory course in the material. And that was still Thursday. And so he had to dig into his advanced graduate course in order to get enough material to cover it. Because the nature of one-on-one tutoring, where you're looking at the student in the eye, you're asking them a question, you're seeing whether or not they get it and respond. And as soon as they get it and respond, you can move immediately on to the next thing. You don't have to worry about what anybody else is doing. You can just gallop through material. There's no wasted time at all. It was just, we were completely amazed by how much material everything was fine. There was one notion of thinking, I guess, thinking logically. So we were interested in studying whether or not our kids were thinking logically. And so we got the idea, there are tests you can use to sort of measure, try to measure logical thinking, which give the students problems like, 5 people are eating apples, A finished before B, but behind C, D finished before E, but behind B. What was the finishing order? When we first gave this to our students, you can probably all figure out that question if you want to work on it. But our students, this was before we had actually taught them anything. It's like in the first few days they were there, we gave it to them. It was mostly blank stares and frustrated sighs as they couldn't make head or tails of it. They had no idea what to do with these. And then 8 weeks later, we gave it to them again. Oops. And what happened when we gave it to them again was that basically they all completed it well. And logical thinking was not anything that any of the tutors covered. They covered their domain, about networking or workstation maintenance or servers or whatever, but they weren't talking about logical thinking. Logical thinking was just something that they picked up.
So I assume you have the hypothesis that their logical thinking would improve when you went into this, right? What gave you that hypothesis?
I don't think it was a hypothesis as much as it was just a question.
Okay,
So, we had the tests. You could get the tests and give them, and they would give you the number. And it seemed like an easy thing to find out. But it turns out that one of the students who basically had been completely frustrated the first time through, worked through the problem employing logic that she wasn't aware that she knew, and just zipped right through it. And when she finished, we looked up and burst into tears. And her voice was trembling, sort of with a blend of wonder and frustration and dread. And she looked at the guy who was in the room and said, "What are you guys doing to my brain?" And her reaction was basically voiced a feeling that pretty much all of our students have at some point in the course from 5 to 8 weeks, where they reckon they come in and they just, their high school education has not asked them to ever think about anything. We believe that they've probably never been asked a question, an answer to a question that hasn't previously been given to them. So they just didn't need to think, all they needed to do was memorize. And here we're now teaching them how to think. So that's what we believe is going on there, is that we actually are teaching people how to think.
What led you to choose to give a test beforehand? Or this and this particular test?
Well, one of the things with the DARPA project is they want to understand kind of what's going on, and so you propose different manners of tracking progress as you go through. And so this also might be getting ahead, but we were working with former head of psychology department at Stanford, Dr. Mark Lepper. He had a battery that he's really well known for the theory of psychology of motivation and how that works. So he's been using a bunch of different tests for how to gauge grit and determination and other things, but logical thinking was also a piece. And so, but having that relationship, we could bring that into the program. So we just wanted to see what would happen. And so there's opportunity to kind of give us baseline to understand kind of what the aptitude of our general student population was. And then since we had these students for a long time and full time, follow up and see where it went.
With an existing body of research that you wanted to be able to situate yourself with it.
In researchers, yeah.
As the weeks continue, the students continue to learn more and more and more, and eventually we got to graduation day at the end of 12 weeks. And so this is our happy graduating class sitting on the sunshine of California coast. So these are the 12 students that ended up graduating out of the 15. And 2 of the Navy Master Sergeants who were with them, teaching them all of the Navy stuff that they had to learn in addition to the electronics that we were teaching them, like how you salute and how you march and how you uniform yourself and how you get a haircut every week and all of that stuff. We lost 3 students for reasons that had nothing to do with academic or the education efforts. Some of it was external activities that the Navy found unacceptable. So the Defense Department has a group called the Institute for Defense Analyses that runs tests. And the Navy, and we also were actually very interested in the question about, okay, you've trained these guys up. Now, do they have the knowledge and skills necessary to be naval ITs? So what we're gonna do is we're gonna take all this stuff that just happened in tutoring and the videos and turn it into a computer program. But we need to make sure that there's the stuff there to train the students up. So if the human experts can't train the students up well enough to be naval ITs, then the videotapes don't contain enough magic for us to be able to get our job done. And so they came up with something they called IWAR, and it had a 1 on it because they wanted to do an IWAR 2 after we finished our job. With the goal of determining whether or not students who went through it gained the knowledge of troubleshooting. The tests were done in facilities in San Diego and included written tests, troubleshooting tests, as well as standing AI watches on docked ships and even ships at sea. So they ran the guys through the experience and tested them really well. So one of the tests was the test of team troubleshooting. So this is kind of canonically what it is that your job is as an IT, since you're working in a group and you have trouble tickets that come in and a group of guys have to get together and fix the problem. So they were doing competitive teams of 3 of our students versus 3 of the fleet ITs, and the fleet ITs had an average of 7.2 years of experience in the Navy. So these were guys who were fairly senior, competing with our guys who had 12 weeks of tutoring by expert tutors. They were given identical faults on identical machines and told to fix them. So we had people setting up tutor machines. So that's what it was that the troubleshooting test was about. And the team either fixed the problem or gave up. And then they were given a different set of faulted machines to fix. And they repeated this over and over and over for 13 and a quarter hours over 3 days until time ran out. And this is viewed by the Navy and us also as the most realistic, representative, and valid assessment of IT readiness for fleet. So, what are the results? So these are the results that came in. So the fleet group is on top. Our student students are on the bottom. So the first column is attempted. First 2 columns are attempted and solved. So the fleet attempted 95 and solved 79 of them. Whereas our students solved a few more, 106, but they solved like 20% more. And which is an impressive amount for guys who were, against people who were 7 years experience. The excellent solution is a rating that they give to the solution when you when you have a trouble ticket, there are often lots of different ways that you can fix it to get it to where the symptom the trouble ticket can implement is no longer, sort of solves the symptom. But it may not, but an excellent solution will be the one that finds out exactly what the cause is and fixes exactly the place where the cause is. As opposed to fixing it in several other places or patching around it, or in worst cases, leaving stuff in that actually breaks stuff later. So
There's your choice. Okay. I just want to hope that we can see some of the material and how they learned as well at some point through this talk. Is that possible?
no, that's not gonna be here.
Okay,
That's not gonna be here.
so it would be nice to see the process.
It would be wonderful to see the process. But it's, yes. It's sitting mothball right now, so it's not running in place.
Who rates the solution?
We have overseeing the entire test is a group of 3 F sets, and the F sets are basically the best troubleshooters, the best IT maintenance guys in the Navy. They're the guys who, if the Navy has a problem and they can't fix it in 6 weeks on the ship, then they ship it to the mainland. If they can't fix it in 6 weeks there, then basically they get an asset looking at it and probably flying out to the ship or going to wherever the problem is. So the assets are the guys who are the best troubleshooting. So we had 3 of those doing the judging, monitoring it and doing the judging. The column for bad changes is when students went in and made a change that later broke something. So those are bad, and our guys made less than half of the bad changes that the fleet ITs did. And the last column was 2 other discipline questions about your troubleshooting strategy. The first one is, whenever you get a problem, the first thing you should do is verify that it's a real problem. Make sure that you can duplicate the solution and see what it actually says, because users are really terrible at describing problems. So you need to see what it really is. So you need to verify it. And then you need to verify that the problem exists. And then once you fix it, you need to verify that the solution exists. And so you can see that our students are better at that because we taught them that every time. We would ding them about that every time as they did do it, and it's stuck. Whereas the fleet learns that on their own. And so, did you have a question?
Yeah, I can't help but relate to this in a way that, like, I was recently interviewing, right, and I was going through the questions, and I feel like there's a factor of knowledge freshness. Like, when I'm practicing for a couple months, I take a test, and I'm at my prime when doing the test. But 2 months later, a lot of that fades away, because, even though I'm working in the field, I'm not working exactly with the set of problems, right? So I was wondering if you were able to do any follow-ups for those students, like maybe 1-2 years later, or account for the freshness or staleness of knowledge in the experienced IT professional.
We were, unfortunately, the Navy is very, very private about letting any information at all about their members, their seamen out. So we did not officially get any tracking. We did get tracking after they had served their term, so 2 or 4 years later, then we could talk to them. And we would get stories back from other people about how they did in their, when they got, after we graduated them, then they would go to their village and be on board, and we would occasionally get stories back from being on board. So we did get the normal sort of pathway, and what we told our students look, when you get on the boat, you're gonna know more than anybody else there. On the other hand, you're the bottom rung. You're, you are the lowest rung, right? And the armed forces work by in a military chain where the guys at the top are supposed to know more. And supposed to be the ones who talk and speak and et cetera. So when you go in, be very, very quiet, listen a lot and talk very little, answer questions if you talk to, but don't get a reputation as a know-it-all. And so our students would do that. And even so, by the second month, everybody recognized that these guys were the guys who knew it all. And within 3 months, they would be the go-to guy. And in many cases, 6 months later, they would be de facto running. Just so they were so educated as to be disruptive. So I hope I haven't given away too much of this, but I'm gonna run out of time before I run out of slides. So the conclusion of the test was that overall, the training appears to have more than achieved its objectives. So the content and methodology incorporated in the digital tutor, the training produced for the students will demonstrate equal or in many cases superior knowledge to the skill compared to experience they do. So both we and the Navy were convinced that the data that we had collected from the school was good data for us to go ahead and do it. Let's see. So we started into a long process of building the tutor, folding it into material. And we started that. We broke into 2-person teams with an author and a content engineer, and each author was a content expert, and they would work on a week's worth of stuff for that particular subject matter. And we worked on those in parallel and spun the stuff out as quick as we can, running courses in Pensacola with getting students from the school there and giving 4-week course, 6-week course, 8-week course as we got the material done and improving it and checking it out. So one of the things that that struck me a lot was we worked on continuously improving the tutor. A wonderful property of having a programmer doing the teaching is that it always produces the same behavior every time. And this means, first off, that you know what it is that the student is seeing. So you know what it is that they know. I mean, you need to test and make sure that they know it, but you know what it is that they're presented to. So you're not surprised by it. Another wonderful property of programs is that you can change it and then it will run a change. So we get cases where a student who was the first guy going through class would run into a bug in our stuff. And we would find out about it in the morning. And if it was an important bug that was a showstopper, then we could fix it and check in a change and get that in so that at lunchtime there we could reinstall it. And then the students after that didn't run into that bug. So it was that kind of flexibility. And we made continuous changes to the tutor every day, but we only put them into the schoolhouse if they were causing the problem in the schoolhouse. Otherwise, we would wait until next week to get them in. But yeah.
And so how do you document that process and the reasons that you made changes and where this improvement to the tutor came from? Because you're fixing and making and building this tutor, there's got to be institutional knowledge so somebody can maintain it later. How do you do that?
There's a corporate strategy. And the corporate strategy for the company we were in is basically the truth is in the code. So if you can't read the code, you have no idea what's going on. So
It's written in what?
I'm sorry,
What's it written in? What's the code written in?
it's written in dialogue language, which was the language that we developed. We had to develop it because of the teaching has some properties that other languages make hard. Like the student can go ahead and make changes to the machine while you're in the middle of talking to them. And so the states that you're talking to them about can change. And you need to get that information back into the tutor. And that's often hard. And complicated. And we had to be able to do it in a way in which it was possible for our authors to write that dialogue.
So is the tutoring software communicating with actual physical machines that put problems?
Virtual machines.
But it did start with physical machines.
Yes, it did start.
And to answer some of this, so Richard mentioned there was a author and an engineer, kind of a pair who would focus on particular sections of content. And so you would have the domain experts that say focus on DNS and and others would focus on Windows server services, for example. And they would own roughly a week of material. And so that expert would understand what's going on, how this is evolving. And some of these would be carried over to the Monterey School. So they'd have the experience in tutoring live, and then they'd have the experience in working with an engineer to get that behavior encapsulated in Tutor. And so they could iterate and watch, knowing both historically what happened with the students, and then watch as new material was placed in the Tutor, which would then also be put in front of students. So you can see how this would iterate in very tight cycles, in a very different way than, say, running it and then letting it go for, say, a year. We would have staggered students going through. In this is what would happen.
Were those engineers correlated or actually the same people as the original tutors?
So the authors, some of the authors were original tutors. The engineers were, we were very close to Stanford, so a lot of folks came in and were Stanford students, grad students who were working on civil engineers, who jumped in and could help out. They weren't necessarily folks with a software background, whereas the authors were folks with teaching and tutoring backgrounds. And it was that meshing of experiences that led to a lot of behaviors that we would get. And one of the major things that we did is flip kind of the authority in that position. So usually you would have, the fancy credential Stanford computer engineer would often be in charge of a lot of the programs that we would do. And we actually deferred to the teacher. We said, you're right, like whatever you're gonna do, whatever you wanna see, we're gonna look at what you wanna make happen. And it ended up being the job of the engineers to kind of work with the author to kind of make very interesting requests come to life in the experience.
So, I mean, so this was something that we ended up doing. Continuous improvement was something that we would do all the time. And some of it was pretty hard. There were some courses that were completely rewritten at least 3 times. Because we would put it out there according to what the expert thought was the right way to present stuff. Which in most cases was somebody who was an author of the book and put it out in the way in which they had talked about it in the book. And it turns out that if you're learning it in a way in which you're continuously working with it, then that doesn't work. You need to know a little bit about lots of different things as you go. And so you need to attack a little bit about each of the concepts so you understand something, and then you can add more stuff. So you need to restructure the way the lesson is laid out. And so you try one that's the one you think, and then you try it on students. And if that doesn't work either, then you try it again based on what you see in the students that are not picking it up. And so it's sometimes it's hard work doing that. But the good news on that is once you get it right, it stays right, and then you can just continuously overhaul. So, motivation. Learning is an effort. And students must be motivated to continue to put in the effort. If they're not motivated, then they're not gonna work. So motivation is absolutely required. When the tutor provides the student with the experiences that lead to real learning difficult concepts, the student is motivated. Okay, that's sort of one of our guiding lights in this, and we work with Dr. Mark Wechter, as Eric said, and he developed a measure of motivation and found that the people who scored highest on this scale were computer gamers. So the guys that will stay up all night long are the guys who are actually looking at the way they look at the screen and stuff. They're the guys who are hiding motivated. When Dr. Wechter measured our students' learning knowledge of the classroom, he would look at it and according to his measures, the scores of our students were as high or higher than the gamers. And it's the only time he'd ever seen that kind of motivation. And we really believe that that's because we're teaching the students. And so what we think is, as long as we're continuing to teach the students complex ideas, and really teach them so that they understand it, they're continuing to motivated to keep moving on to the next thing. The education really is ecstasy. They quote a book like the 60s about learning. Okay, so now there's this section. So Ted, how it feels like we've been asking questions, which I think is great. Do you want me to stop? I mean, I had been assuming I would talk until 8:30 and then we would have talk.
It's up to you.
But it seems like everybody can ask questions.
They seem to be willing to ask questions and you just keep going.
So I'll just keep going. And
How much more is there? It's probably another 5 slides or something or more.
I'm on slide 17 out of 51.
Well, I don't think anybody wants to stay here till midnight.
So I will.
So how do you want to choreograph this? Do you want us to shut up and listen?
No, I hate to kill good interaction.
Okay.
I think that I think you give me a 10-minute warning and I will skip to the end.
We have a tendency to expect that if you speak for an hour, then we ask questions for 20 minutes, and so you've got another 30 minutes.
Okay.
That's about enough.
Okay.
At that point,
So in that case,
you'll have people going to sleep.
one of the things I wanted to do was kind of give a sense of when we write a content module, the sort of changes it went through, and particularly because this is a computer human interaction group, I wanted to include some stuff about how the computer, the user experience and the user interface really is creating the experience, and the experience is the thing that the student learns from. So UI and user experience is completely essential to teaching by computer. I can't imagine anybody. You end up with very robotic instruction, which students hate if you're not paying very careful attention to it. So and the example I was going to walk through is teaching a troubleshooting strategy. This slide up here with the massive aircraft carrier was supposed to give you the sense about what it is that our ITs are walking into. So they arrive on a helicopter or a jet, in the backseat of a jet, and then plop down on its carrier, which has 5,000 people on it, and probably has hundreds of servers and thousands of workstations, and routers and switches all over the place, and redundant networks and all kinds of things, and expect it to fix it if somebody has a problem. And so one of the things that you need when somebody, basically a trouble ticket comes in, and says, networks going out various places. You need to have the students need to have a strategy for how they're gonna go about finding that. It's needle in a haystack stuff, and if you're not well trained, then you'll never find it. So we have a troubleshooting strategy that we teach. And I'll go through this at a very high level. This is the framework for teaching troubleshooting. So number one, I talked about earlier, it confirms that the problem actually exists. Number two is you need to know all the faults that might occur on your network that would cause the observed symptoms. So this requires a lot of content knowledge about whatever it is that you're doing. And we call that collection of faults the hypothesis space. So that someplace in that set of things is the problem. One of those guys is the problem. Then you perform an experiment or a test of some kind that gets you some evidence about what's happening. And then you take that evidence and you look at your hypothesis space and you remove all the faults in the hypothesis space that would generate behavior different from what was observed in the space. So basically you run an experiment, you go through the hypothesis space, marking off all the ones that don't show up. And then you look at the hypothesis space. If the hypothesis space has one fault left, then you fix it. That's it, and you fix it. And actually, this is more at the level of trying to find the area. Because the hard part, if you're on a carrier, if you can find the machine that's the problem and figure out which part of the machine it is that is the problem, then your life is basically an easy city. Because that's a very bounded problem. So by finding the fault, what we're really talking about here is getting to a place on a machine that you know is the broken area. And fixing it might involve determining exactly why it is this IP address isn't right. But you know the IP address isn't right. If there's still more than one fault, then you need to find an experiment that will cause some of the remaining faults to give different answers. So the way we sometimes speak about this is ideally you would split the hypothesis space. So you do an experiment for which half of the guys, the remaining hypotheses would give you the right answer and half would give you the wrong answer. That's the optimal way to do it, but we don't stress optionality at this point because we're just trying to get people to move. If it even removes one fault and they keep going at it, they will eventually get there. And there's something nice about having that confidence. Even if you're not sure that you can find an experiment that splits it exactly in half. In many cases, we'd rather do one experiment in which they hack off part of them that don't worry about optimizing it to get it exactly right. So after you pick the experiment, then you go back to the level 3. So that's the thing that we're trying to teach. And when we did human tutoring, we didn't focus on this. This was picked up pretty much by every tutor in their unit, requiring this kind of behavior by the students. So we never talked about strategy, but the students picked it up and developed it on their own, but it wasn't anything that they learned. So when we were doing the tutored version, we thought, well, we can do better than this by actually focusing on teaching it. So we started with an easy to understand example. And actually, speaking about history, we began with a game that we introduced in Sophie, which was an electronic system that John C. Brown and I worked on, called Attribute Blocks. Yes.
There was a question from the chat about your hypothesis space.
Okay.
And that was, what percentage of problems encountered are novel, perhaps not in the hypothesis space?
Well, we don't have a hypothesis space. The person who's using the strategy needs to find it. And so it is the case that if for example, Microsoft has just released a new version of something. And the user is using it and you haven't heard that they're using it. There might be some issues that you don't have any idea about it. And you need to figure your way out of that. But that's a problem about maintaining your database of knowledge about what it is that the systems that you're running on are. But nobody knows all of them anyway. But by following this, you will eventually get to the place where, I mean, if you eliminate all the hypotheses in your card, then you need to think of something else.
That's where you get to Sherlock Holmes.
So,
Another way to think about that is if you're working on a complex system and you know how components of that system behave, you can operate at a fairly high level and then carve out that space and get down to a spot where maybe that area is novel, but at least you've isolated a chunk and may have to explore that on its own. So, you know, like a new update, for example.
okay, so and the game was one that I developed in 1974. And attribute blocks. Attributes blocks have been around for a long time. There are collections of blocks you can see at the bottom of the screen that have different attributes, color, typically color, size, and shape. And they're typically used. Typical use is with students that will have a loop, and they will ask the students to turn over a card and put all of the blocks that match that attribute inside the circle. So they're typically used for students to learn what properties are, and learn about shape recognition and color recognition and that. And so they've been used for that. But one of the things that what I did was make a game out of it that could be used for troubleshooting. And so we changed it so that the card is face down in the game loop. And the student has to get information by asking the tutor where a block goes. So the tutor is the one that places the block. It knows the rule and it will place the block either inside or outside, depending upon the value of the rule. And the student is supposed to gain information by placing blocks. And they're supposed to place blocks until they know what the value of the card is. And then they're supposed to say, yes, I know what the value of the card is and what is. So this turns it around. And this is a good model for the troubleshooting strategy. It has a nice hypothesis space. The hypothesis space is all the possible values that are on the cards. So they break up into, in our case, big and small for size, red, green, blue, yellow for color, and shape, circle, and triangle. So it provides the students with a nice concrete view of what a hypothesis space is and why it is what it is, and what role it plays. And now I'll walk you through this. Placing the block is doing an experiment. So in this case, the student chooses to place a big blue block, and based on the value of that rule, the student places it inside the loop. From a troubleshooting perspective, that's an experiment. So that's the experiment. So the next thing we need to do is look at the hypothesis space. And have the student ask the student which members of the hypothesis space are eliminated by this experience. So that when we first get started with the game, we actually force the student to do this. They go through it after every time they place a block, they have to mark out. And so basically you'll walk through this quickly. We have a large blue square inside, so can it be big? Yes, it can be big because it's the block inside. Can it be small? No, it can't be small because there's a large block inside, and if there were a small block, if it were small, then that block would go outside, it would be inside. Its color, could it be green? No, because if it were green, then the blue block would be outside. If that, say, a lot of it appeals to red and yellow. So it could be blue, but it can't be any other color. And shape can't be circle, it could be square, but it can't be triangle. So that's the reasoning that you can do to eliminate reasonably lots of hypotheses. So placing one block in the middle, you've eliminated 6 of the hypotheses. And so you know that if you know it has to be big, blue, or square. So this already has gotten the students through a lot of hangups that have prevented them from understanding how to use the troubleshooting methodology, understanding what the ramifications of their measurement are, what an experiment is good for, and all of that. So it's already been incredibly useful, even without anything else. So the student must close out all of it. Here. So this come to bring, so at this point, we're at step 5. We look at the hypothesis space, there are 3 there, so we have more than one. So we need to pick another example of something to do, and you want one that basically would have a different plan. So for example, you could pick a small red circle and be guaranteed that would go outside. So that's not interesting. So there are experiments that are valuable and there are experiments that aren't valuable. So there's already there. So you need to pick one which is either not blue or not big or not square or one of the two or two of the, you know, they can't all be either in or out. They have to do mix to get it out for the 3 attributes. So we're going to say that the student picks a small red square. And the tutor says, oh, okay, the small red square goes inside. And so now this, so now can the size be big? Can't be big because there's a small inside. Can the color be blue? No, it can't be blue because there's a red thing inside. So that means we can rule those out. And it has to be square. So now we know, so we've got one single hypothesis. So in 2 blocks, we've been able to figure out what the rule is. And then the student would get something that allows them to say which of the hypotheses is it, and they would say square and have solved the game. So the quick outcome of using attribute blocks is that the students selected, the act of having the students select eliminated possibilities facilitated them learning to recognize that they knew lots of stuff that they never thought of. Like having a blue block inside means that the rule can't be read. So the very act of going through the fact of using that knowledge was new information about thinking. And turned out to go a long way towards getting them. As a side, I mean, we found the student enjoyed the game and mastered it and played with it. We had a version, we would take them through, we would tutor them on how to play it, and then turn them loose playing it, and they would play it for an hour or 2 before they got tired of it. But they definitely enjoyed doing it. But they didn't apply the strategy to solving network problems that very much. So the jump between attribute blocks and real networks was too great. So we developed a different version of attribute blocks, which used network. And so we came up with the network troubleshooting game. So this game is, the goal is to identify the broken machine and where the machine is failing, which is what we argue is an important property of finding your way to complex exercises. So the game had a simple network with a fault in it and a limited number of faults. So that we could run this game very simply. And so the network you see at the bottom has 2 servers on the left, 2 routers in the middle, and 3 workstations on the right. So that's our network, which we have to know. And the introductory, in order to make it basically sort of flavor it for the way it works in the Navy, we have a trouble ticket, and the trouble ticket is it has been reported that the users are having trouble accessing files shared on other machines in the network. So each of the servers and each of the workstations has files that they are sharing over the network. And the complaint is that from some machine, it can't get to some other share. And that's very common that users will not tell you which machine it is that they're trying to get to and which machine they're running on. So you'll probably have to figure it out for yourself. So that's good exercise for them to figure out for themselves. So for the networking, the hypothesis space is a little more complicated. What we did was to break the faults into 4 layers that correspond to the levels in the internet stack. Those being physical, link, transport, and application. Physical is your cable connected. Link basically is, do you have an IP address that it belongs on the network? And transport is, do you have a way out to get to the router and get to other networks? The application are the shares on the machine working. So that's the application is sharing files. So that means that we can, the tests that we have to run are very simple. Then we have this problem with the 2 routers in the middle. The transport layers and all of that is basically for every internet connection. And so each of the machines has 1 of those, but the routers have 2 of them. 1 on each of the networks belong. So there are actually 3 networks here. There's the 1 on the left, the 1 in between the 2, and the 1 on the right. And the routers have to be able to carry the packets across that. So it's simple, but it's got a little bit of complexity in it. So then what are the experiments that you can do? There's limited experiments that can be run on the machine. So basically the equivalent of doing an experiment is you can pick from accessing a share on computer X from computer Y. So you log in any machine and try to access the share on any other machine. You can ping by IP address from one machine to another. You can check the routing table on the router. That's in there because the router has a routing table, and the only way that you can find out what's in it is to check it. So that has to be there, right? I mean, it only applies to 2 machines, but you need to have it in order to just figure out what the problem is. And the other one is checking a link line. So we don't have a physical connection. So we have an experiment you have to run. So if you want to go look and see whether or not the green light is on, you've got to run that as an experiment. So the tutor will select what experiment to run from a menu that has all of these things in it with parameters for the machines, what necessary. That tells the student what experiment to run. Then the tutor places the experiment inside the loop if it fails and outside if it succeeds. And you can switch those so that it doesn't make any difference whether the fails go inside or outside, but it makes things a little bit simpler, I think, to think about if the ones that fail go inside, because it's more unusual. But kids get used to it, so whichever one you do. So here's the game. The student selects accessing the share on server 1. From router from workstation 2. And so I'm going to switch to the next slide. So that we actually have, and I'm going to put my cursor, and my cursor doesn't show on that screen. Okay. And I'll dive. Oh, I do have a cursor. But I can't get it over there. I can't. It won't let me.
What do you mean?
Okay. Okay, so I'm gonna forget about that. So what happens is that accessing the share, so we would be on WKSO2, which is the middle workstation on the right, and it will send a request for share, which means that it's going to be testing its transport link and physical levels. It's not going to be testing its application. So the three, since the experiment succeeded, everything that's along the path from WKSO2 to the server is great, and we can eliminate. And so you can trace through that, and if you trace through that, you get basically all of those members of the hypothesis space are greened out. You know, the routers are all set working, you know, servers 1 is all working, you know, WKSO2 is working, except possibly it can be having trouble with its shares. You don't know that. So you've eliminated all those hypotheses. So, and then you go on to the next one. So this is a fairly interesting game that has some interesting, you can learn some interesting things. In fact, there's a
Basically, what you seem to learn is to be methodical.
well, that is, yes. You learn,
Yeah. That's the interesting thing, isn't it?
well. Yeah, though,
But following a particular method.
Yeah.
Well, understanding the model of the system you're applying to. And so if you can be methodical and actually slot in what your experiments or what your experience is telling you, that gives you the ability to say, okay, where is the problem, or what could be going on, or where could I focus an experiment next?
But earlier in the talk, you pointed out that after you were done, you gave them a logical question and they were able to do it.
Yeah.
And so what they really learned was being methodical. Is what my takeaway is. Am I right, or I don't know? That's.
and I don't have any idea whether you're right or not.
Well, but you did present the experiment of asking them a logical question that had nothing to do with it, they learned. But
Well,
required
I
logic.
believe they're learning logic. And if that's what you mean by being
The methodical.
methodical, then yes, they are doing more logic effective. I don't know. I don't believe logical thinking is a monolith that you learn all at once. I think that you learn how to apply it in different situations. And you learn more complex. So I agree that they are learning. So
Except you showed transfer before, where you gave them a problem that had nothing to do with the domains that you've asked.
yes,
And that's what you were kind of showing off, that they'd actually succeeded at.
right.
So that shows transfer, which is one of the things that's very, very difficult in education. Typically, transfer doesn't happen. People are only good at the skills that they've learned. So when you've achieved transfer, that's very exciting.
Yeah.
That's all.
Yeah, one of the longitudinal studies, when we actually did this program with civilians, we followed up after several years and watched them go out of the program, get into industry and see where things went. And that was one that just kind of blew our minds. We basically didn't find any of them that were doing the skills that we taught them directly. They all kind of relearned new skills that built on what were there, and were in slightly different roles than we had trained them out of the gate. And so it definitely spoke to potential for transfer at a high level.
So the networking was an improvement. Many more students started using a troubleshooting strategy, but there were still students who couldn't make the jump. So I came up with the idea of actually putting the hypothesis-based marking over top of the machines. so that they can operate on that. And that helped a lot. Or he's shaking his head so you can understand why that would. And you would be thinking yourself the way I was about why did you do that, right? Why did you do that in the first place?
Well, it gets rid of an indirection. Right, you don't have to have a label representing something over here, it's directly.
Right, it connects to what that is, okay. So with that, and again, this is all what I would consider user interface design and improvement of all this stuff. So, so now I want to give you an example of what the tutor screen looks like. So this is the best I can do with respect to
I
what
was hoping for,
so, and I think I'll probably stand up, I don't. And use my finger on
but we
the
are getting to, in 5 or 6 minutes.
5 or 6 minutes, okay. Well, basically, this is a chat window, which is the conversation between the student and the tutor. And normally that would fill in this entire half of the screen for conversations. But this particular screen is of packet tracer on a network. It has a network. There are packets on the network. This is a list of all the packets on the network, and you can select one of those and it will fill in what type it is and what all its values are. And then if you want to control any of those machines, this lets you select which machine you want to control, and then you have ways of configuring it and ways of running command on it. So the student has complete control over that from this interface. So it's a complicated interface with 7 different panes. And that's the best we could do for that. So there are the things that we're having the student do really are complex and they really are real. So this is the Cisco packet tracer, which is the teaching tool that they use for getting all of the details right. Another common widget that lots of our authors use will allow you to bring up a network of as many as 17 virtual machines on the network and connect to any of the 17 and operate on it. So the students really are working on real machines all the time.
You can actually click on that guy
You were asking,
and then mark up the screen itself. I just discovered that.
I think it's a little bit late for that. Okay.
so they're there looking.
This is a picture of early cases. This is in Pensacola of some students running the tutor. So you can see that individually a student has an monitor and they run and they typically wear earbuds. It's set up so that the dialogues that are presented automatically start getting read, and you control the voice, you can control the speed that happens at, you can turn it off. But most of the people leave that on. And one of the things that we've found out is that our interface doesn't put people who can't read very well at a disadvantage. So reading comprehension is not a good predictor of how well you're going to do in the course. So we've managed with the various other things that we've done to make it so that not being able to read is not a hindrance. So after we produced the 16-week course, and then the Navy wanted to do their summited IWAR 2. And so they ran another IWAR competition. The tests were very similar to the previous IWAR. This time there were 3 test groups. There were the guys who went through the digital tutor course. There was also a pilot 36-week classroom that a different group at the training center in Pensacola was trying out. And so they were trying something that was more focused on getting credentials and learning, networking. So they were taking 35 weeks to do it. And then our fleet ITs, senior fleet ITs were, this time they averaged almost 10 years of experience. And were selected further, they were selected for their superiority. So it was the best guys that we could find with the most experience, not just the random guys. And our master sergeant did that for us, help us out. And the results of the tutor test in this case, troubleshooting exercises. The digital tutor team substantially outscored fleet and under IT graduates with higher scores at each level of difficulty, less harm for the system and fewer unnecessary steps. Individual tests for digital tutor graduates also substantially outscored fleet ITs and ITPS graduates. Finally, reading ability measured by a standard test of reading, vocabulary, and comprehension was found to account for very little variance in the IT knowledge of a graduate, but about 25% of the variance in the IT classroom. So the way the other guys were doing really made it really difficult. Didn't have that. So this is a slide showing the various groups. So this is a chart I took out of it, and I glued in the ones which were the digital tutor on the left, and then the yellow ones in the middle are the fleet, and the ones on the right were the alternative course. And you can see that in the gray is the ones that were completed. So you can see that our guys really did much better than either of the other two groups. And apropos of the discussion that we just had about developing the troubleshooting, there's one of those categories was very hard, and you can see that the fleet and the ITT guys wouldn't even try the very hard ones. But our guys tried 5 of them and solved 3 of them. I guess they solved 3 of them, 60%. 60%. And missed 3. So they solved 5. So to solve a very hard problem, you need to have a good troubleshooting strategy. You can't solve a hard problem. And so this I took as an indication that our code now for teaching troubleshooting strategies is working, because we've trained guys up in 14 weeks. So give a quick story here. One of the things in the evaluation was the Navy had a panel of their FSETs, who were the top troubleshooters in the class. So they were interviewed by a panel of 3 of the guys. So for 15 minutes, they would ask questions of each candidate, sample candidates from both our class and the other class, the ITTC class. Asking to rate them in 5 areas that were happening. So as the 4th candidate walked in, one of the ITs turned to the guy next to him and said, "I can tell which group this guy coming in is just by the way he walks into the room."
That's
Just more confidence.
Just more confidence. Our guys walked into the room like they knew what they were going to do, and the other guys walked into the room like they were expecting to get. And then during the evaluation, in the 5 areas, one of our students got a 5 in 4 of the areas and 4 in 1 of them. So he's got 5, where 5 was basically, I would like to have this guy working with me on the FSETs. And the leader of the FSETs said about this guy and told him, basically, "I would like to have you come work with us right now. I would love to have you as a colleague."
There you go.
Okay,
A
and
test that's an interview.
and that. Every time I think about that, it completely amazes me. Because here's somebody who didn't know anything about computer maintenance. And went through a 16-week course that I helped build. And now the best troubleshooters in the Navy want to work with it. And that's, when I think about that, it's just amazing to me. That the stuff that I did had that amount of effect. And I really, I look at that and I go, we really did capture the teaching in there. This thing has to be teaching. It has to be teaching at a level that we've never seen before. And so that's where it is. I would like to,
We are. We've gone even farther than.
farther than we want. I do want to mention that these ideas are continuing on. The philosophy that we have, which is in the slides, is being continued on by a group that worked with me, including Eric, who's CEO of Acquisitive, which is the company that's following on, trying to repeat our experience of this time doing it in grade school math tutoring.
In what?
In grade school math tutoring. So right now, I'm working with the company that we're trying to put together tutoring lessons that will do for kids in grade school what we did for the ITs and Navy training.
And the IT stuff is also continuing or not?
The IT stuff is in mothballs. It fell upon bad politics, fell upon bad personalities. It fell upon hard times. And is.
No, it's, you're not in
They still
control.
have a website, but it's sputtering along and I haven't heard. They won't respond to my call.
Well, we lost one of our star debugger, actually. But I want to thank you for this talk, and if there's any existing questions or follow-ons. One that came online was a woman asking, how did you choose your students and your experts and your testers, and you just went over that though. So I don't know if Roberta wants to open her mic and ask more question about that, but you can if you'd like, Roberta.
If the Navy supplies the students, we have no control over the students.
Yeah, you can figure out where they're at when you start.
Yeah, thanks for asking, but the question was answered in the meantime. Thanks so much.
Thank you, Roberta. Yeah, so you checked them out at the beginning and how well they read and stuff or not.
I don't know whether or not we did the test, but it didn't make any difference. We were gonna do the same thing with it. But of course, everybody does the same thing. Some people get through it, get through more. So we were doing 5-day courses, which we needed to do because we were setting it up in a classroom and you had to march through and you had other classrooms coming in and whatever. So we were forced to structure it, and we ended up with some people who would get through the content in a day and a half. And so then we would try to think of auxiliary content, which were things that weren't strictly necessary, but were other subjects that were related to that.
Some people have extra enrichment.
And that extra enrichment and stuff, and ended up building a large body of that in order to.
So are there any other questions maybe?
So brief question, is Exquisitive for profit?
It is a for-profit company. We're looking to basically get into the market, attract good talent, and see kind of what was going on. We're focused on really how do we do this? How do we get really great, high-quality teaching and tutoring to younger students in a way that's accessible and inexpensive. And when you can capture teaching and instruction on a computer, you can do things at a level at scale where currently, if you're going to get a human tutor in the Bay Area, you'd be looking at $100 or more an hour. You can do things where an entire month, fraction of that, $10.
You don't have any nonprofit branches or?
Not at the moment. We're actually thinking about what that could look like and how to do that. And then one step forward that I just want to get to, when we heard that Richard was going to do this about attribute blocks, wanted to put together a little bit of a demo. I know a lot of this talk is, okay, so what does a tutor feel like? What does a DARPA tutor system behave like? Our current system has a very similar feel. So we did put together a demo that we can share with your group and folks that are on there.
How are you showing this?
Through a URL, I can share a URL, and it's a tutor, so it's best experience kind of one-on-one as you sit down and go through it. I can send it to you. The actual URL will be /A blocks, capital A, capital B blocks.
This.
It'll get you there. That'll get you to our website, but if you add an A blocks, capital A, capital B, you'll get right there. Fire it up. No login, nothing else required. Just we'll show you what some of the attribute blocks.
A blocks.
A block, yes.
All right, we'll try to remember that. And are you funded and hiring, or are you fully full, or what are
It
you?
has been a fascinating experience. So it's lots of attractions and the tutor ties. So at the moment, not quite hiring. We're trying to get a baseline into the market where we look at where entry will be. So developing a K-12 or math curriculum focusing probably on second, third grade to start. And should hopefully be releasing the first bits of this in a little bit.
When?
As actual products, you're looking at your next milestone, or is that like beta releases and testing stuff?
It would actually get released hopefully in the next week to 2 weeks.
Oh, you're there.
Yeah, we're working with another company, which I shall not name now, where this has been on the market and has been used in a different form. It's captured about 25,000 students who have been able to use it for different aspects of K-5, and they really enjoy having the experience. They find it very different from normal classroom and normal applications that you might find on the say on the App Store.
We did have a question from Jeffrey Burton asking how this might differ from the experience of Khan Academy, which I have no general description of in my head.
The primary difference, like if you go to Khan Academy, what a lot of it is a lot of videos where you have somebody standing up in front of the screen, and it's very much a broadcast medium. So in essence, captures some of what you have here, where somebody's talking and the student, it's not at the pace of the student's learning, the student is following at the pace of the video. And there have been some elements that try to make videos a little bit more interactive or stop and ask a question. But it's usually, most of these experiences usually video and then questions. And the questions are usually, is it right? Or if it's wrong, they give you a hint. It's not conceptual, it's not trying to build an idea of what the model should be. And it kind of leaves the student to work on their own to fill in the gaps, as it were. The major difference here with this kind of approach is we're building the curricular experience and showing the students the concepts the first time through while having their hands-on in the experience that it was. When it was DARPA and the Navy, they're on there working on machines day one, right? They're active. Here it's, you're building problems or you're experiencing those attribute blocks, as it were. And the demo would show it to you. Immediately you're engaged. The other aspect is, and probably you'll see this in the attribute blocks demo, the first interaction you get is going to be a question. We're going to ask you to participate. And so that the dialogue nature is something that's dramatically different.
That makes sense.
It's a box.
A block.
A block, yes.
Okay, that's exciting, and I think people can go and discover what is going on there, and hopefully keep track of exclusive over the next couple of weeks, and find out that they heard a little whisper of a secret here that they find out more about. Next month we're gonna hear from about a book that just come that's been written. Let's see, who is it? It's Suzanne, Suzanne, anyway, Curry. So she's gonna be speaking about the books that she's written. We have a bunch of other good speakers every month coming in. We will decide if this is a great place to continue, and that's gonna be based on whether it brings more people here. You like it? You like it?
Yeah, because I'm never really finding in the city.
Wow, that's great. Yeah, so that's a good thing, and it's on freeways from every direction. And with that, thank you so much, Richard, for coming. Thanks for everybody that was online for coming as well. And I got messages from several people that said, oh darn it, I can't come this evening, but I'm gonna watch the video as soon as it comes out. So I think that you're gonna have some more attraction. We've found over time that when we release a video, often it gets multiple times the number of people things within the first week that we had even in place. So they've been good, and we've had, everybody from, Don Norman to Ben Schneider and, Peter Norvig and so on. So a lot of interesting people, and please check out the Facebook and tell people to come and be part of this. Have a good evening. Take some chocolate on the way.